In this video we're gonna be doing this question paper. We're gonna be focusing on 6.1. So let's say we're given this problem. Let's try to solve what is being asked here. The statement says the reaction is initiated by heating 83.4 grams of PCl5. What do we know? Just we need to collect the data first. We know the mass initially. It is given for PCl5. It is given to be 83.4 grams in a sealed 2.00 dm cube. So that means that is a volume for this process. So it is given to be 2 dm cube. At equilibrium, it is found that the initial concentration of PCl5 has concentration at equilibrium. It has a concentration. These brackets means the concentration PCl5. It is X mole per dm cube, right? So if that is the case, let's try to solve and get what is being asked from us at equilibrium. We are being asked to show that the equilibrium constant Kc is x squared over 0.2 minus x. Definitely what we need to do first, we need to find the molar mass for PCl5, right? So P is phosphorus. If we can look at the periodic table, we will find P is at which block? It's here, which is 30.97 plus Cl5. That means it's chlorine times 5. So we are going to check in the periodic table the molar mass for chlorine. Then molar mass for chlorine is 35.46 times 5 because of this number here. So let's press in the calculator and see what do we get. 97 plus 35.46 times 5, and we get 208.27. 208.27, that's grams per mole. That's our molar mass. Definitely this is not the end. We need to find the number of moles. Like, let me give you the hint. When you are given 6 marks questions and you see that you have a clue, you just need to calculate everything that you know, everything that can give you more marks, even if you won't get the answer correctly. But these things are needed. You just need to collect your data properly, then you calculate what has to be calculated. So let's go and find that number of moles, which is N, is mass over molar mass, right? This is molar mass, this is our mass. So we're gonna find our number of moles, and it's 83.4 grams all over 208.27. And let's see what number of moles are we getting over that answer. It was, so our number of moles is 0.4 0.00 if you can know what a significant figure. So we are trying to take the significant figures here. So let's take two significant figures. So it's 0.40 mole. This is our number of moles. If you remember or recall, also number of moles is concentration times volume, right? So we can calculate the concentration initially, because initially we were given the volume of 83.4, and the number of moles initially we calculated and we found this. So let's find the concentration initially. So our number of moles initially is 0.40. C, we calculate for concentration initially, because the concentration given there as X is at equilibrium, not initially. So our volume was given as 2 dm cube, right? If we divide by 2, we get C. This is for PCl5 because the question is based on it. So 0.40 divided by 2 is 0.2 mole per dm cube. Sorry for the space. Concentration for PCl5, 0.2 mole per dm cube. Then we need to go to our ICE table, where we are talking about the equilibrium, right? And put our equation here. What was our equation? It's here. So it's PCl5 PCl3 plus Cl2. Right, you can do it to be nice for you. So initially what was given, let's do it like this. Initial, what was given? Initially we given, or we found PCl5 to be, because here we are going to put the concentrations, we found the concentration to be this one. So initially the concentration is 0.2. The statement gave us nothing about this and that, so let's put 0 here and 0 here initial. There is no statement based on these two, because this is a reaction, or sorry, this is a reactant and this is a product, right? This is a product. Yeah, for you to be able to understand. So if we can see this, or the concentration from, it is from this side and it is going to that side, so we can simply say that the change, because now this is initially, this is change, this is equilibrium. So we were given at equilibrium that what was given equilibrium, we were given at equilibrium that the concentration is X, right? Then so we can say now, since we have 1 mole ratio here, because it's 1 1 1, right? So we can say it's X X X. Now, which ones should be negative and which one should be positive? Which axis which x is this one, this one, this one should be negative. We can be proudly to say that the x value for the reactant should be negative because it is decomposing to the product. So we can say this one is a negative x. Since the reactant, our reactant is only one, so we're gonna have only one x, right? Let's say if you were given like to be 2, the coefficient for this PCl5, if it was given to be 2, you were going to say it's minus 2x, right? If it was 3, we're going to be saying it's minus 3x, etc., etc. So guys, now we are at equilibrium, right? So at equilibrium, we simply say initial plus change. So it's going to be this plus this, that plus that, that plus that plus that. Then let's do our thing. So this plus this is 0.2 minus x. This plus this is x. This plus this is x. This is our equilibrium. Now our ice table is complete. Now the question asked for constant equilibrium, which is Kc, right? So if it is Kc, the formula for calculating Kc, it says that product over reactant, right? So our product at equilibrium, because Kc means we are talking about, or we are based on equilibrium. So equilibrium, the information for equilibrium is here. So our Kc will be, our product will be x plus x, right? You see? So let's say this is our product. This bracket, guys, means for concentration. Simply means because PCl5. Let me put it here because I'm running out of space. Let's put our concentration, it's x and another x. The product is 0.2 minus x. I substituted, this here, this here, this, you see. So if we multiply, we get x squared 0.2 minus x. This is the final answer, guys. Thank you for watching. So don't forget to like, subscribe, and hit the notification bell.